So how do you factor a trinomial or a quadratic expression? Now the process of factoring is turning the area as a sum into the area as a product. Now before I show you guys how to factor, let's practice multiplying out the two binomials. In other words, let's practice turning the area as a product into the area as a sum. So we're going to do that by drawing a generic rectangle. So for example, let's say we have 2x plus 3 multiplied by another binomial, 5x plus 2. We're going to use a generic rectangle to multiply it out. Let's see what we get. Okay, so now we're going to write the area as a sum. In other words, we're going to add up all the pieces that we have left. So we have 10x squared plus we have 15x and 4x, which are like terms, which combines to be 19x. And lastly, we have 6, so plus 6. So there you go. The area as a sum is written as 10x squared plus 19x plus 6. Now pay careful attention to where the 19x came from. The 19x came from combining both x terms. In other words, we combined the 15x with the 4x, which combines to be 19x. Now there's something else interesting about these generic rectangles. Let's take a look at the diagonals of the rectangles. So if you look at this diagonal, 15x and 4x, we see that when they multiply 15 times 4, we have 60x squared. That's because 15x times 4x gives us 60x squared. But what about the other diagonal? Well, we have 10x squared and we have 6. But if we multiply that diagonal, 10x squared times 6, we also get 60x squared. So it turns out when you multiply both diagonals, you get the same result, 60x squared. Now this is actually true for every generic rectangle that you've been doing. Every time you multiply the diagonals, they produce the same result. Now we're going to use that fact when I show you how to factor a trinomial. Let's try our first example. Okay, so here's our very first example. We have an area written as a sum, and we're going to turn that into an area written as a product. That process is called factoring. Okay, so here's the first step. Our first step is to draw a generic rectangle with 4 quadrants. Now we can look at this expression and already fill 2 sections of this generic rectangle. So we know that the 2x squared goes into this section of the rectangle. And we also know the plus 3 goes to this section of the rectangle. Now the only thing we have to figure out now are these 2 empty spots. One thing we know for sure is that whatever x terms that goes in here and whatever x term that also goes in here, when they combine, they should add up to 5x. Okay, well there's many options to that. We have 1x and 4x, we have 2x and 3x, we even have 5x and 0x. All of those combinations add up to be 5x. However, there's also one more important fact that we have to remember. Now recall that every generic rectangle that we've been doing, when you multiply the diagonals, those results should be the same. In other words, when you multiply a 2x squared with the positive 3, we get 2x squared times 3, which is 6x squared. Now, that diagonal, the product of that diagonal must be equivalent to the product of the other diagonal. So in other words, we have to come up with 2 expressions that when you multiply them, it's also 6x squared. But when you combine or add those two, that diagonal, you get 5x. Now to organize that thought, we're going to produce something called a diamond problem, or an x game. You can draw an x like this. Now we know that two numbers here, or two expressions, must multiply to be 6x squared. Now, the two sections of this diagonal must also combine to be 5x. Now, when we solve this diamond or the x game problem, these two numbers must multiply to be 6x squared. But when you add, you get 5x. So what two terms multiplies to be 6, but add, you get 5? Is it 4x and 1x? Well, 4x and 1x adds to 5, but 4x and 1x does not multiply to be 6x squared. The only option here must be 3x and 2x. That makes sense because 3x and 2x multiplies to be 6x squared, but when you add them, you get 5x. So this is the solution. We're going to put 3x into this section of the box, and then 2x into this section of the box. And there you go. Now all we have to do is to find the length and the width, the dimensions of the generic rectangle, then we're done, because we can just write the area as a product as length times width. So let's go ahead and figure out the length and width. Let's go ahead and figure out this section of the generic rectangle. We can look at these two and see the greatest common factor, or what do they have in common? We see that these two both have an x, and the greatest common factor is then 2x, because they also both divisible by 2. So we have 2x here. Now once you know that this is 2x, you can kind of figure out the rest of the generic rectangle, the rest of the length and width. So for example, if this is 2x, then this is 2x squared. 2x times something gives us 2x squared. So what is that something? What multiplied by 2x gives us 2x squared? It must be x. That makes sense because 2x times another x gives us 2x squared. Now what about this section of the length? So right here we know that the area is 2x, but the width is 2x. So 2x times something gives us 2x. In this case, it'll be 1. That makes sense because 2x times 1 is 2x. Now, what about this section of the rectangle, this width? Well, we know that this length right here is x. So if this is x and the area is 3x, then what times x gives us 3x? Well, for this must be 3, because 3 times x gives us 3x. Now, before we write it as a product, let's just double check our work. We just gotta make sure that every section makes sense. 2x times x gives us 2x squared, 3 times x gives us 3x, 3 times 1 gives us 3, and lastly 2x times 1 gives us also 2x. So everything checks out. And there you go. So the answer is 2x plus 3 times the other binomial x plus 1. And there you go. That was our very first example of factoring a trinomial as a product of two binomials. Let's try another example. Okay, so now here's another example. We're going to factor a trinomial into a product of two binomials. In other words, let's write the area as a sum into the area as a product. So our first step is to draw a generic rectangle. Now, just by looking at this expression, we already know the two spots of a generic rectangle. We know that 3x squared goes on this section of the rectangle, and then the plus 8 goes into the other side, the other corner, the opposite corner of this generic rectangle. Now, what do we know about these two empty spots? We know that these two empty spots, when you combine them, has to add up to 10x. But when you multiply that diagonal, it has to be the same as if you were to multiply the other diagonal. So in other words, when you multiply this diagonal, what do we get? 3x squared times 8 gives us 24x squared. Since we know that 3x squared times 8 gives us 24x squared, that means whatever this times this must be has to equal 24x squared as well. So let's go ahead and organize that into a diamond problem. So we know that these two expressions must multiply to be 24x squared. But when you combine those two empty sections, we must have 10x. So let's go ahead and figure out what two numbers multiplies to be 24x squared, but when you combine them, you get 10x. Now we can make a simple list of two numbers that multiplies to 24. So let's try 1 times 24. Well, 1x and 24x should not combine to 10x, so we can immediately rule that option. What about 2 times 12? Now 2 times 12 gives us 24, but when you combine them, it does not give us 10x. Now what about 3 times 8? Or what about 4 times 6? Now all of these multiplies out to be 24, but only one of them gives us a sum of 10x. In this example, we see that 4 plus 6 must be 10. So the solution to this diamond problem, or the cross game, is 4x and 6x. 4 times 6 gives us 24, but when you combine them, you get 10. Therefore, these two empty spots must be 4x and 6x. Okay, so now we're ready to figure out the length and the width of this geometric rectangle. So let's go ahead and find this length of the rectangle. Now to look at this length, let's take a look at these two and find the greatest common factor of 3x squared and 6. Now looking at these two, we see that they both have a factor of x, but they also both have a factor of 3. 3 can be divided into 6 and 3. So therefore, 3x is a common factor of 3x squared and 6x. Now that we know that 3x is in this side of the rectangle, we can pretty much figure out the rest of the rectangle. So if 3x is here, and 3x times something gives us 3x squared, that something must be x, because 3x times x is 3x squared. Now, based on this information, we can also figure out what this side must be, because x times something gives us 4x. In this case, that something must be 4, because 4 times x gives us 4x. Now we can figure out this width of the rectangle. If we know that 4 times something gives us 8, that something right here must be 2. Now we always double check to see if everything matches up. 3x times x gives us 3x squared. 4 times x gives us 4x. Then we got 4 times 2, which gives us 8. And last but not least, 3x times 2 gives us 6x. So everything lines up. So we're done. Now we can write the area as a product to be 3x plus 4 times the x plus 2. And there you go. Let's try one more example. Okay, so now here's our last example. We have a trinomial and we're going to factor that as a product of two binomials. Let's write the area as a product. So again, our first step is to draw a geometric rectangle with 4 sections. And we already know the 2 sections of this geometric rectangle. We have 4x squared, which goes on this section of the rectangle, and we know negative 15 or minus 15 goes on that section of the rectangle. Now, what do we know about these 2 empty spots? We know that when you add those 2 empty spaces, we have 17x. But we also know that the product of that diagonal has to be equivalent to the product of the other diagonal. In this case, when we do 4x squared times negative 15, we have negative 60x squared. That means these two must also multiply to be negative 60x squared, but when you combine them, it has to be 17x. Let's go ahead and organize that into a diamond problem, or a cross game. So these two sections must multiply to be negative 60x squared, but when you combine these two, must be positive 17x. So let's come up with a list of two numbers that multiplies to be 60. Well, we have 1 and 60, but 1 times 60 gives us 60, but doesn't combine to be 17. By the way, one of these has to be negative because the product of one and the other must be negative 60x squared. So one of these have to be negative. So let's try 2 and 30. Well, 2 and 30 multiplies to be 60, but it doesn't come out to be 17 even if one of these are negative. So if this was negative 2 and positive 30, they do multiply to be negative 60, but negative 2 combined with 30 gives us 28, not 17. So let's try 3. 3 times 20 also gives us 60. Again, one of these two has to be negative because we want a product of negative 60x squared. So let's see if we can somehow make them combine to be 17. Now in this case, it can. Well, which one has to be negative though? If it was 3 times negative 20, it does multiply to be negative 60, but 3 times negative 20, or 3 combined with negative 20, gives us not positive 17, but negative 17. So the negative should be on the 3. That way we have negative 3x and a positive 20x. So let's see if it works. 20x times negative 3x does in fact gives us negative 60x squared. But when you combine negative 30x and 20x, we get 17x. So this checks out. So let's go ahead and fill those in. There you go. Now we just got to figure out the length and the width. So let's go ahead and find this section of the rectangle. What is the greatest common factor of 4x squared and 20x? Well, clearly they both have an x in common, but what's the greatest common factor of 4 and 20? Well, 4 and 20 can both be divided by 4. So the common factor is not just 4, but it's 4x because they also have an x in common. So the greatest common factor is 4x. Now we know this piece, we also know what the other sections must be. So 4x times something gives us 4x squared, and that something must be x, because 4x times x gives us 4x squared. Now what about this section of the rectangle? 4x times something gives us 20x. Well then this must be 5, because 4x times 5 gives us 20x. Now what about this section of the rectangle, the length? Well, x times something gives us negative 3x. So this section must be negative 3, because negative 3 times x gives us negative 3x. Now we always double check to see if everything checks out. 4x times x does in fact gives us 4x squared. Negative 3 times x gives us negative 3x. Negative 3 times 5 does in fact give us negative 15. And last but not least, 4x times 5 in fact gives us 20x. So everything works out. So let's go ahead and write the area as a product. 4x minus 3 times x plus 5. And there you go.